All right, this is the 2013 rates question. So what we got going on here is we have gravel that's arriving at a processing plant, and it's arriving at the rate of GFT measured in tons per hour. It says in the question too that it's being processed at a rate of 100 tons per hour, so we want to keep that in mind. And there's 500 tons of gravel to begin. Okay, part A asks us to find G prime of 5. So you just hit math 8, type in 5, and the calculator spits out negative 24.588. Well, G's already a rate, so G prime is going to be the rate of the rate. So what you can say is that the rate the gravel is arriving at the processing plant is decreasing at a rate of 24.588 tons per hour squared. All right. Part B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation. So if G is the rate that it's arriving, then when you integrate G, you'll get how much arrived. So math 9, type in 0, type in 8, type the function in, hit enter. 825.551 tons. Part C, is the amount of unprocessed gravel at the plant increasing or decreasing at time 5? Well, the rate that it's arriving at time 5, you just plug a 5 in to GFT and you get 98.141. It tells us that the rate that is being processed is fixed, and that's 100 tons per hour, and 100 is bigger than 98.141, so it's being processed faster than it's arriving, so the amount of gravel at the plant would be decreasing at time 5. And then part D, what's the maximum amount of gravel what's the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? So, all right, I have written an equation for the amount of gravel at any time, and that's equal to what you started with plus what comes in minus what goes out. Okay, now you can put these two together in one integral if you want to. I did in my work that's going to be posted. Okay, and so we have to consider our endpoints. So I'll be plugging a 0 and an 8 into this equation. Okay, when I do that, I get 500 and 525.551. Maximums could also occur when the derivative is equal to 0. So you derive this guy and you get G of t minus 100. That's just the second fundamental theorem happening right there. Okay, he equals to 0 at 4.923. So now I need to figure out how much gravel is at the plant at time 4.923. So I go back to my A of t equation, and where I see t, I replace it with 4.923, pops out with 635.376, and so that's the answer, that's the maximum amount. Please click on the link with my work solutions, and you'll see everything that you need to there. Okay.